Okay, now we're ready to start Digestion 1. The digestive tract and the things it does. It's like one long tube that starts at the mouth and ends in the anus, and it's amazing all the things that the digestive tract does. And the cat, dog, and horse are great animals to compare. Those are our focus animals. And they're great to compare because they're all basically different in their taxonomy, at least how they're classified digestive wise. So this will be very interesting. Now I first want to start with a table that I made of the 6 classes of nutrients. So let's get this enlarged. I'm going to go through it a little bit, but at the end of the presentation there's a link stated. This is called Table 1, I believe. You'll see it at the back. Let's go through this real fast. Water, protein, carbohydrate, fat, you might call them lipids, vitamins and minerals. Those are the 6 basic nutrients. Now I'm on top. Sometimes you'll see a table that says the 7 basic nutrients. And within the carbohydrate, we do have fiber, and some people separate out fiber as the 7th basic nutrient. And it's kind of like economists. Not everybody can agree on everything. But I'm going to let you read this, but water, there's 3 sources. Most animals have 60-65% of their body weight is water. A lot of reactions taking place in water. Proteins are amino acids linked by peptide bonds. It's the only nutrient that contains nitrogen. And sometime later I'm going to tell you about the food poisoning that happened with dogs and babies, unfortunately, where somebody unscrupulously, my tongue is getting tied here, up the nitrogen content with a poison to get more money, because if you're selling protein, the more percent protein it is, the more money you get. But you can elevate the nitrogen from non-nitrogen sources. Anyway, here's a good point. Absorbed as monomers and dimers. All our nutrients are basically polymers, long things usually, and they have to be broken down into their simple units to be absorbed into the body, the animal body. And so that's the case with a lot of these things. And if there's excesses, of course, if you eat no matter what, it almost is always stored as fat. Unfortunately, protein is a very expensive nutrient when you're making diets. Let's see, carbohydrates, provide a lot of energy, but if you have excess, stored as fat. Fat, energy source, easily digestible, and it contains 2.25 times the energy of carbohydrates. Then we have vitamins. Of course, I'm going to let you pause and you can read every little detail. Vital amines, that's where their name came from. But they're used in metabolic reactions and enzymatic reactions. You can have too little or too much. Some can be synthesized by the body, like vitamin K by microbial populations is a very good example. The liver stores a lot, usually what's called the fat-soluble vitamins. There's a lot of interaction sometimes between vitamins and minerals. And then you should know that vitamin D is actually a hormone made by the body. And although you can get it in food sources, but the vitamin is actually made by sunlight impinging on the skin, and that a certain molecule goes to the liver, and then the kidney makes active vitamin D. Minerals, there's a lot of minerals. There's trace minerals, there's macro minerals, and many are involved with reactions, metabolic reactions. Of course, calcium, a lot of calcium in bone, I should say. None of these minerals can be synthesized by the body, so they always have to come in with the diet, like iodine. A lot of people, especially in the world, lack iodine, and I think when we did talk about the thyroid in the endocrine section, we talked about goiter. Some of the minerals are stored in the body, like calcium in bones. Man, the bones are a depot tissue for calcium. They can give up calcium, especially when an animal's lactating. Anyway, read that, study it, it's good. Now we're ready to talk about our 3 focus animals. Here I've got a horse. I'll get this up and enlarge it. Somebody drew this. It basically shows, the mouth is the most cranial part of the digestive tract. Then we have this tube that may not be just a tube, but bigger chambers. But then we end up in the anal area. That's the GI tract. For the horse has a relatively small stomach. Its natural history is that it takes in a lot of little meals over a long period of time, maybe 14 hours. So it's always eating, but not eating a lot at any one time. And we have the small intestine, the cecum, and the large colon. We'll find out in the horses. These guys are very important. So now let me pull down some words. Horses can be called monogastric. Monogastric, one stomach. They can also be classified as an herbivore. They have plants is their food source. They don't really eat any animals. Okay? And then another thing is they can be classified as a hindgut fermenter. Now, what a hindgut fermenter does is in its cecum and especially large colon, there's a microbial population that is able to work on cellulose. You should realize that no animals can digest or break down cellulose. It takes cellulase, and microbes are good at that. So a hindgut fermenter can get some volatile fatty acids and maybe some vitamins like vitamin K from this fermentation process. But it's not as efficient as if you were what's called a foregut fermenter. Because when you ferment in your hindgut, you get some volatile fatty acids that can be absorbed through the epithelium of the digestive tract, some vitamins, but you don't get any of the microbial proteins, the proteins that are in the microbes that you could break down, but that happens in the small intestine. And here we are, a hindgut fermenter. All that stuff is happening after the best place to absorb proteins and digest proteins. So they're not as efficient as what we would call ruminants. And so a horse has to be fed a better ration. Sorry, the tongue's getting tied here. A better ration than a cow, for example. Okay, cats are an interesting case, so let me bring down a couple diagrams. Here's the digestive tract of a cat, and all members of the cat family, lions, tigers, and so forth, are very similar. Of course, it's a tube. Some people say it's a tube within a tube. The tube starts at the mouth and ends in the anus, and there's a lot of things going on, but it's still a tube. Okay, well, cats, I've got this diagram here, or a picture I should say, to remind me. I'm going to put that right over there because you can pause and look at that diagram on the left if you want. I'm going to cover it over. And this picture reminds me to say that cats are obligate carnivores. In the natural history of cats, their entire meals have been animals. And over the millennia, they have lost some enzymes. They didn't use the enzymes, so they lost them, that can do certain things from plants. So a cat is an obligate carnivore. It's still a monogastric because there's one stomach, but cats are a special case, and I've got a table coming up, or some statements at least. But this cat shows it's going to eat this mouse. And you should always know that these animals eat their prey head first. The reason is it's easier that way, because then as it goes down the digestive tract, you're not going against the flow of the hair of the prey, because most of the prey, the hair is folded back. So it would be harder to swallow a mouse, if you were a cat, swallow a mouse tail first, although I'm sure some try it. And then here's an interesting picture. Of course, not all cats eat rodents. Here's a picture of a cat that has a rat as a buddy. And so this rat is climbing all over the cat, and the cat has no desire to eat its buddy. Okay, now I'm going to show you a few reasons why cats are called obligate carnivores. Remember, they're monogastric, they have one stomach, but then more importantly, they're classified as a obligate carnivore. Let me enlarge this. And obligate means must have. So a cat is an obligate carnivore. It must eat meat. Now I compiled this list here, but not everybody would agree totally with everything I have here. So that's okay. This is, I guess, my interpretation of why cats are obligate carnivores. Taurine is an essential amino acid for a cat. Essential. That means must be in the diet. If you ever see something that's non-essential nutrient, that means the animal can probably make it from different precursors. But taurine is an essential amino acid. A lot of animals can make taurine, but the cat cannot. Arginine is an essential amino acid for the cat. Now, that's not on every list, so if you find a list that doesn't list that for the cat, don't be surprised, but I'm listing it there. Here's an interesting thing. Cats are unable to convert beta-carotene into vitamin A. Beta-carotene is the precursor molecule that can be changed into vitamin A by most animals. And I wanted to show you, just before I made this presentation, I was making up dog food. I feed my own dog food. So let me just put this up here and show you. It's not complete yet in this picture, but as an ingredient, white rice, carrots, and broccoli are some of the ingredients I put in my homemade dog food. I don't feed commercial dog food. Just wanted to say that. So the dog can convert the beta carotene in these carrots to vitamin A. The cat can't do that. Okay, back to the list. Some lists show a lack of ability to make sufficient vitamin D. Now, vitamin D is a hormone. It's kind of been mislabeled, but sometimes people say the cats can't make enough vitamin D. So if you can't make enough, and sometimes some of these things are not found in the plant world, like vitamin A is not found in the plant world. So the kicker is animal tissue and juices have these things in them. So cats, going on now, cats have an inability to make sufficient arachidonic acid from the precursor linoleic acid, fatty acids. Cats also need niacin. They can't convert tryptophan to niacin like a lot of animals do. So that's my reasons why cats are obligate carnivores. And then down here I put some other interesting facts that you can read about cats. Maybe one thing is cats were originally desert-dwelling animals and they don't have a strong thirst response. So they sometimes tend to get dehydrated. Here's one interesting thing. They don't need carbohydrates in their diet. When they're eating animals, animals don't have many carbohydrates in the body. There's glycogen in the liver, glycogen in muscles, some, but not a lot. So if cats have always eaten meat, they don't really need any of the carbohydrates in their diet because they've always been eating animals that hardly have any carbohydrates. Okay, very interesting. You can read the rest of the list. Okay, now we're going to compare our next animal, the dog. Here's the dog. Digestive tract mainly, of course. Let me get my laser pointer going. The liver. The liver is in the abdominal cavity and it's usually cranial to the stomach. So there's got to be a diaphragm someplace where I'm drawing. Okay? It's maybe not the best drawing. But again, the dog is a carnivore. That's the order that they're in when you look at the taxonomy of these animals. It's an order, the carnivores. But unlike the cat, who is a strict carnivore, dogs are not strict carnivores. They can get along with eating meat and so forth, but they don't have to. So then some people call dogs omnivores. An omnivore is somebody that can live on plants and animals as feed sources. So, dog would love to eat meat all day, but they do have the ability to live on plants. So, very interesting. Now, I just wanted to show you something I found on the internet that I thought was very interesting. Somebody who has more artistic ability than me talked about monogastric digestion. Remember, that's one stomach, and I'm going to enlarge it as much as I can. And then, of course, you can pause and read this, but it really shows a good knowledge of digestion. For example, nutrients are combined with salivary amylases in this animal, monogastric. Could be a dog, can't be a cat because cats don't have salivary amylase. Anyway, shows it coming in. Here's the stomach. It's talking about intrinsic factor, maybe something we'll talk about later. It binds and helps you get vitamin B12. Pepsin sometimes is given, and it helps protein digestion. You get bile salts from the liver put into the small intestine, very close to the exit where it comes out of the stomach. And you can just read this yourself, but I just thought wow, if a person could do that, drawing, and explain it, they know a lot about digestive physiology. They've got the 3 sections of the small intestine listed, and then the colon, they haven't separated out large or small, that's fine. They haven't really shown a cecum, so it's not perfect, but it's really amazing all the little things that they've got listed here. What's being absorbed and bile acids being absorbed. We haven't really talked about that much, but some of the bile acids are recirculated back into the liver, which is amazing. I just thought that was a neat little diagram saying, hey, that person really knows their stuff. And finally, I wanted to end by showing you a couple books that exist where if you want to learn about the nutrient requirements of our focus animals, dogs, cats, and horses, there are these books put out, and I'm trying to enlarge that as much as I can. They're put out by the National Research Council, and they're not published every year because there's not enough changes in our knowledge every year. In fact, the book that's shown right here, I've got sitting right beside me. They're rather expensive. I think it's $150 because they don't print zillions. And it's highly specific information. But I'll tell you what, if you want to talk about or learn about dog and cat nutrition, it's a great book to look at. You know, you can go to your library and find it. Okay, so that's a great book. Put it right over there for dogs and cats. And then, if you're interested in horses, another of our focus animals, here it is. I think both of these books were published about 2006, 2007, something like that. They're both, you know, like I said, about $150, maybe up to $200. But it's kind of like the Bible of nutrition for horses in this case, and the Bible for nutrition of dogs and cats. Excellent stuff. And finally, here's a list of the illustrations I used for this lesson. Thanks a lot. See you again sometime soon.